Hello, welcome. Today let's try to solve another Leetcode problem. 2218 maximum value of k coins from piles. So we are giving a number of piles. Inside a piles, it's a stack of coins. So a stack of coins means we have coins like 1, 100, and 3. And for the second pile, we have 7, 8, and 9. And if we are going to calculate the k equals to 2, so we are going to take 2 coins. So what is the maximum value? We can take this 1 and 100, so this is the maximum value. But you cannot take something like 108 because you have to take from the top. You cannot take it in the middle. Yeah, you have to take the coins from the top of the piles. So this is why I'm going to solve it in a prefix dp. Now let me go to the whiteboard to explain my solution. After that, I will go to the code editor to finish the coding. So according to the drawing, we can do something like this. So basically, this is also a DP problem. But for this problem, we cannot use other ways to check one by one. I mean, we cannot check the coins in the middle or from the bottom. If we use a top-down solution, we're gonna check the coins from the top to the bottom, one pile by another. So for the first piles, how many coins we can try? So if k equals to 2, so it means from the first piles, we can choose maximum of 2 coins. If we choose 1 coin, yeah, imagine only we have 1 piles, not 2 piles. We only have this left piles, we only have 1. So if k equals to 2, what is the maximum? If we only choose 1, so it is 1. If we choose another one, it is 100. So the maximum is 101 because we only have 1 piles. What if k equals to 3? If k equals to 3, it means from the first pile we can choose 3 coins, the first, the second, the third. Yeah, so the result is 104. Yeah, so the problems becomes difficult when there are many piles. It is not 2, it may be many piles. So how should we solve it? So we can solve it in the same way. It's also the brute force approach. So the brute force approach is we're gonna try the first pile, how many we can try, and what is left. So for example, if we try 1 coin from the first pile, yeah. So for the first pile, we can decide if we are going to choose a coin or not. If we are going to choose and how many we can choose, yeah. So now we are going to do 2 things, choose or not choose. So let me first analyze the not choose. If we are not going to choose the coins from the first pile, so how many coins we can choose from the second to the last pile? So I mean from here to the last pile. Yeah. So how many we can choose? We can still, if k equals to 2, it means we can still choose k coins because we didn't choose anyone from the first pile. Yeah. So if we choose 1 coin from the first pile, how many we can choose from the second to the last? Yeah, it means we can choose k minus 1. Yeah, if we choose 1, it will be k minus 1. If we choose 2, maybe 1 and 100, how many coins we can choose from the second to the last pile? It means we can choose k minus 2. Yeah, so we are going to check all the cases by that. So for this, and then after finishing analyzing of the first pile, we are going to check the second pile. So in the second pile, how many we can choose? Can we choose 1, or can we choose 2, or can we choose 3? Until we finished all our piles. If our piles is out of range, for example, I use index I to represent the piles. So the index will start from 0, yeah, to n minus 1. So this is means the I means the index of the piles. So it will start from 0 to n minus 1. So if this I equals to n, it means I go out of the range. So I will return a 0 because I don't need to add anything. So this is one thing. And also for the k, from the beginning k equals to 2, and finally k might be minus 1, minus 2, until k equals to 0. So 1k on, so this is or, I equals to n, or this k equals to 0. It means I gonna return a 0. I don't need to do anything. But for my recursive function, DFS function, I need to return a 0. Otherwise, I gonna check all combinations. For example, for the first pile, I'm going to choose 1, 2, maybe 3, but k equals to 2. It means I can at most choose two coins. So I will choose 1, 2. And after that, I'm going to choose for the second pile. If I didn't choose anything from the first pile, so from the second pile to the last pile, now I'm going to choose from the second pile. I can choose 1 and 2. Yeah, I will do the recursive function until I go to I equals to n or k equal to 0. If there's no coil, or if the I index no pile goes out of range. Yeah, so this is the whole function. So but between this 1 and 100, we're gonna use the prefix to plus this 1 to 100 if we choose 2 coils. If we choose 3 coils, we're gonna use the prefix 1 plus 100 plus 3. It means we're gonna choose 3 coils. Basically, this is a brute force of DFS search. But for the search, we're gonna use memory because inside the DFS, it will be I and K. Yeah, so the DFS will be I and K. This I means from the first pile to n minus 1 pile. Yeah, and this K means I'm gonna choose K coils. So from all the piles, I choose K coils, and finally I'm gonna return a result. So my return for the result is just a number. This is why I can use memorization for the DFS to solve the problems. Yeah, and the time complexity is I times K. Now, for the I, it is from I to I minus 1, it is the length of n, so it is n times K for the time complexity. Yeah, and the space complexity is a recursive function. Yeah, basically for the recursive function, it is I times K. Yeah. So for the maximum I, it is still n. So the space complexity is still n times K. Now let me go to the code editor to finish the coding according to my analyzing of the problems. So I'm going to prepare a variable n equal to the length of the piles because I'm going to check for my DFS function. And I'm going to use a case, otherwise it will be time limit exceeded. Now I'm going to define my DFS. So the DFS will be I and K. So this I means from the first pile to the last pile. It means from 0 to n minus 1 piles. This K means I'm gonna choose K coils. Yeah, and I'm gonna give a pass first, but finally for my function, I'm gonna return DFS from 0 to the K because I'm gonna choose K coils. Now I'm going to write the DFS function. As I explained earlier, so the condition is if I equals to n, it means I have no piles. Or if this k equals to 0, if I have no coils. If I have no piles or I have no coils, so I'm gonna return a 0. Yeah, so this is just the end of the recursive function. We must find the boundary cases, the add cases for our recursive function. Now we are going to define 2 variables. So the result will be the DFS. So this means I will not choose any coils from the first pile. So it will directly go to the next one. This means I will go to the second pile to the last pile. It will be I plus 1. And did I consume any coils? No, because I didn't choose any coils. So it will still be K. So this is one variable. Now I'm going to check the second condition. So this condition is not choose from this pile, not choose coils. Yeah, not choose any coils from this pile. So this is the result. Now I'm going to check the conditions for if I choose what if I choose any coils. So how many coils I can choose? So for I in range k. But inside the piles, maybe here is 3 and 3, but you can see here in the inside the piles there's only one coil. We don't know the height of the piles. We don't know how many coils inside one piles. So we have to choose a minimum. Yeah, we have to use a minimum with this k and the length of the piles. So this is the maximum of coils we can choose from a certain pile. So the length of the piles I. So for example, from the first pile, so the maximum of coils we can choose is 3, but we only need to choose 2 coils. So it means inside for this variable should be j, we're gonna only choose 2 coils maximum. But yeah, but we can choose 1 or 2, so we're gonna check one by one. So here I'm gonna use a prefix sum plus this piles ij. So this means from the ith pile, I'm gonna choose the jth coil. So if j equals to 0, it means I'm gonna choose 1 coil. If j equals to 1, it means I'm gonna choose 2 coil, because this is the prefix sum. And before that, I'm going to define a variable. So the variable will be prefix sum. It's gonna be 0. So here, this means I'm gonna choose this coil for the first pile. Then I'm going to check the result. So I'm going to check one by one to check which one is the maximum. Yeah, so this is like the brute force. But for the brute force, I use the prefix sum. Yeah, actually the brute force works because I use the memorization. So for the max of result, so this means for this one, if I do not choose, it means from 0, I didn't choose. And then I'm going to choose 1 or 2 to check if it is the maximum result. Now I'm going to choose it. So inside it will be DFS. Now it will be I plus 1. I will go to the next pile. Yeah, if I choose from the first, and then I go to the next until to the last. So it will be I plus 1. And how many coils if I choose? Yeah, if I choose, for example, if this j equal to 0, it means I choose 1 coil. Yeah, this j equal to 0 doesn't mean it didn't choose. If this j equal to 0, it means I've already chosen 1 coil. Yeah, so inside it should be, let me check. So yeah, I think it should be, yeah, k is the coil minus j. J is 0, but actually j is 1. So this is why I need also to minus 1. This means how many coils left. If j equal to 0, it means I left behind k equal to 1, k minus 1 coil. If j equals to 1, it means I choose from 0 and 1, I choose 2 coil. It will be k minus 2. Yeah, is left behind. From the second, I left behind k minus 2 coils. I'm sorry, it's not coils, it's coils. Yeah, I choose 2 coils. Now let's check if the function is okay. Now I finish all my function, but I need a return. So this is my final return for this I and k. But for the recursive function, I call the function from the top to the bottom. So this is a DFS top-down DP, dynamic programming top-down solution. But for the recursive function, actually, when I call the function, I call this one and this one until I go to the end. So the end cases is I go to the last pile go out of the boundary, and I go to the last coin. So actually, for the function calling, it is a bottom up, but for my solution, it is a top down. So that is why we will call it top down DP solution, because we analyze from top down. We are not analyzed from bottom up. Yeah. Now let me run it to check if it really works. So the piles. Now let me check again. There's something wrong. Let's debug. Yeah, my output is 0, but the expected result is 101. It means something is wrong with my function. So here is a prefix sum. I calculated the prefix sum, but I didn't add it to my result. So this is why I get a wrong, I believe. So the result should be maximum of result with DFS I plus 1. It means I go to the next one. This means what coins are left, k minus j minus 1. So I need also to plus this prefix sum. So it means I already take how many I've already get the profit and how many values I can get. So this means from the first pile, I get this kind of a value, and what's left behind is DFS. Yeah, so I'm still coding until I get the maximum result. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass to all the testing cases. Yeah, as you can see, it passed all the testing cases. Thank you for watching. Now let me analyze the time complexity again. So the time complexity is just I times k. So the maximum of I is n. So it is n times k. And the space complexity is just the depth of the recursive function. So for the recursive function, it is, let me check. So I think for the depth of the recursive function, it is how many coins? I think it is k. Yeah, I think it is k. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problems like this. See you next time.